Good morning, or lunch, I guess, almost. I'm going to talk to you about alternative fragments today, and in particular two libraries by Square, Mortar Flow, and how I've been using them in a project for about a year now, and just kind of walk you through some of the different aspects of the libraries, how you can get started with it, and I have a sample project that you can check out afterwards. So yeah, my name is, first I'm going to go a bit background, like how I use it, why I got started with it, then some details about the libraries, and the deep dive is just looking at the particular components, and then we'll look at a live demo afterwards. So my name is Thorben Primke. I work for a company called Jelly Industries. We're in San Francisco. I joined the company about a year ago, and we had a Q&A application, mobile only. It was like a new spin on Yahoo Answers. And that application was rebuilt using Mortar Flow because its UI was quite unique and fluid, and it needed to be very performant. So we're using just regular views and needed something to actually manage the interactions, the backstack, and things like that. So at that point, Mortar Flow was still very early on, but we gave it a shot, and it worked quite well. Actually, about a month after I started, we started working on Jelly to start on a new project, which at the time wasn't as complex from the UI, but we discussed whether we wanted to switch back to just use fragments, which I had been using before on several projects, but decided to stick with Mortar Flow, and I believe in the long run that has been really paid off. More to that in a minute. But yeah, the app uses just a lot of like regular screens with list and recycler views. But mainly, I mean, I think the benefit from Mortar Flow is the very clean architecture, model view presenter. So some of the background, like the activities in fragments, and when fragments became really popular about 2012, people started converting the activities to fragments to get some performance boost there. They were initially intended to, be used for master and detail layouts for tablets and make that easier, but also turned out that you can just use fragments within fragments and use the FragmentManager to really manage those transactions and get a performance boost there, since you're avoiding the overhead of the activities creation. So yeah, use a single activity and cache your fragments, but then you run into a few problems occasionally. On resume or on attach fragment, your fragments might not be in the right order as you've seen them before, especially if you use only like hide and show to not replace them and get the caching effect. As you want to do some transactions, you might run into illegal states, and a lot of the code becomes very defensive. And also, a lot of the logic, business logic and view logic is all cluttered together. So, if you don't want to use fragments anymore, I think there's the solution. It's Mortar Flow. You have a single activity. That's how I built Super. It has one activity and just plenty of views inside of them. And you need a backstack management to do that yourself or to start from scratch. It isn't too hard, but if there's already another solution out there, why not try it? So, Flow. It's available on GitHub. It was developed by Square. It's still in very active development. Very recently, maybe about a month ago, some more stable and new APIs came out. Also bad for people who are already using it because it kind of broke things, and now it takes quite an effort to actually update to the latest version. So what does Flow do? It provides a way to define the screens and handles the navigation between them. It describes the screen. So each screen has a screen and a presenter inside that comes from Mortar. That's the second library. The screen can also have things like a particular state. For example, you're passing in some variables for that screen that you want to pass to your presenter. Those are attached to the screen and also handled during the persistent state of the screen. So you can really store information along with the screen itself in the backstack. It handles the history and the persisting. And similar to nesting different fragments to maybe encapsulate a compose flow, you can do the same thing with Flow. It's open source, so if there's something that you're missing, but you need for your application, you can always build it yourself. That's how we kind of went about with the nested flows. Mortar is the second piece of it, also from Square on GitHub. It kind of provides an overlay on the application lifecycle and shields a lot of it from your presenter. But it provides access to things like a bundler service. So any of your classes can now store things in a persistence bundle. And it also works very nicely with a Dagger. In order to make Dagger as well as the bundlers or these different services available throughout the application, those are attached via the context through get system service, and you override get system service to actually hook in your particular Mortar scopes. So Mortar, as I just mentioned, has Mortar scopes. You start with like a root scope of things that you want globally to be available. Goes to your activity scope where you will expose your activity so you can later inject your activity to any of your presenters. I'll have an example for that in a minute. And the scopes can also be used so you can really like separate different pieces within your application. Let's say you have one part of your app that's authorized, but if the user assigns out you in an unauthorized flow, you can use two different scopes in order to actually provide different dependencies. So yeah, the bundle service, that one is just so that the activities persistence bundle can be easily utilized in any class, particular the presenter, which is already like built in, but anywhere else you need it, you can inject it. And yeah, it provides the view presenter or presenter that within your screens, your presenter always extends the view presenter, so you get all the persistent state for free. As I mentioned here, we're using the save method. So now when we look at combining Flow and Mortar together, they don't necessarily have to be used together, but Mortar without Flow is not that useful. So both together really provide a nice package. So again, Mortar leverages the get system service to provide access to persistence bundle as well as dependency injection and whatever else you wanted to hook in there. The view presenters are now easily testable. Your logic is nicely separated. As far as the object graph, each particular screen extends it, so over time it builds up, but also as you navigate out of screens, those get torn down. So you're really keeping a very thin objects, or your object graph is very thin. And, sorry. Yeah, based on the MVP concept, both your presenter and your view know by each other, talk to each other. When the view gets initially created, presenter is informed so that things like any data from the model can be passed back to the view and set up. And then, yeah, lastly, Flow provides backstack, as I mentioned, and provides the definition of the screens. So let's actually look at how like you would go about setting it up, setting your screens and your views up together. So here we have a like pretty basic screen. Could be a fragment, could be anything, but it's just views. In this case, I think of frame layout. if we look underneath, we can see on the left side, the main screen. On top, we have definitions for the layout that's used. So that's automatically taken from the screen, as well as the module. So the module is where you would add additional dependencies that you wanted your presenter to be able to be injected with. Below, you can see the onload and onsave methods. Onload is called after the view is created, so that anything that was injected into the presenter can now be passed to the view and initialized. Onsave, save any changes to the view, either in the persistence bundle or within your presenter itself. You also notice that the presenter is singleton. So what that means is even when your activity is destroyed on rotation, your presenter actually persists. So any state that was within the presenter is still there after your activity and views get recreated. On the right-hand side, we have the main view, main screen, main view. This one is nothing much is in there. I abstracted a lot of the logic. On the top, you see a class custom linear layout. And if we look at that, it actually handles first with the object graph service. So that's the service that's used with Dagger for dependency injection to inject any dependencies. In this case, it was actually the main screen presenter that gets injected into the view. And then on attached window and detached window, the presenter is again informed about the lifecycle events, so that you can either set up the screen or save anything. And since this is a lot of boilerplate code, I abstracted it, and now your regular view looks pretty clean. And here is mostly click handlers using a butter knife. So let's take a look at Mortar scopes and how they work. So everything starts with your root, and you usually set that up within the application itself. When you set it up, you can start with an object. See in the other screen, we have the object graph service. So that's the first one you would set up together with your module. In this case, it would be your application module. I think I'm showing it in a minute. And then that new Mortar scope is being used within the get system service method, so that when a particular service is requested, it can be interfered. And if it matches the particular Mortar scope, that one is returned, so that any like in the case of the object, I'll just show an example in a second. And the second piece is that the scopes can be extended. Earlier I mentioned about the auth and unauth, but I also use extended scopes or extend the scopes for a particular thing, such as a wizard. So we see that here where from the activity scope, I go usually down to the main screen scope when that one is shown. But in order, before I go to a wizard, I inject another scope that contains information how the wizard, about the wizard state. This way, this particular state can be injected on all the different screens. So from the wizard scope, we go to wizard screen 2. And again, because in the hierarchy of Mortar scopes, it's below, all the dependencies that are created within the wizard scope can be easily injected and used. So here we see what I was mentioning earlier, how you set it up within your application. The first time the get system service is called and root scope is null. We set it up. We initialize it with the object graph service and the root module. In this case, it's the application module, which also gets passed an instance of itself so that later on the application can be injected in any of your presenters. This is the application module. You can see it also includes other modules via Dagger for the action bar as well as settings. And then the module exposes the application, as I just mentioned, so you can use it in any of your presenters later on, or presenters, other controllers, wherever you may need it. So here's the scope example with the wizard, and I think this should play. Okay. Yeah, so here you can see the wizard starting, and we're going from screen 1 to 2. Each time you go in between, we increment a counter. That's just some value I'm keeping a state with. And as you can see, when we're done and return back to the main screen, that wizard scope was removed. And the second time we go into the wizard scope is added again and basically reset. So this way you can always just keep a very clean state of any of those subflows within your application that may need the same dependencies each time, but you want to only maintain them while within that particular flow. So as I mentioned earlier, the presenter is a singleton within that particular screen. And so because it's injected into dependency, injected into the view, it's only created once. And so screen rotation is this way handled very nicely in the sense that your presenter is actually not recreated, so no additional overhead there. And so here we can see, we go from, here again we keep on a counter. That counter is simply within the screen. Presenter singleton, and we have this one value in here, onload count. That's just incremented each time we go through the onload method. As you can see, I don't actually save that. You could also add the initial additional saving into with the bundler service into the persistence bundle, mainly for your application actually getting paused. In that case, obviously the presenter is torn down as well, and so you need to have this set up so that the screen on in the flows backstack can be saved properly. So next up, flow navigation. It's actually pretty simple. There aren't that many methods anymore. It used to be a bit more complex, but they cleaned this up in the latest release. So there's really only a set method and a set history and a go back. The set method, so this is the first line, set new settings screen. It behaves differently depending on whether that screen is already somewhere on your backstack or not. If it's not on a backstack, it will be added to the top and displayed. If it's already on the backstack, all the screens above it will be removed, and the new instance or the previous instance will be shown. So it kind of goes backwards in that case. Otherwise, so if it's not there, forward, otherwise backwards. Set history, you can just start with a clean slate and initialize with a few screens if you want to prep your application is starting up and you're going immediately to a detail of maybe a post, but you also want the feed below it, so you can initialize the history and with the main screen, or maybe with the feed first and then with the detail afterwards. So your user will first see the detail, but on back press you see the feed. History at single is just a helper, so you don't have to go through the builder. And go back is a simple back functionality. If you trigger it like from not within the back button or the action, the toolbar. So if you have anything else that causes the back navigation, you can call it directly on Flow. Since we covered the navigation, doing that navigation, you also want some kind of screen transitions. That's something that doesn't come out of the box with Flow, but in Square's sample library, they have a simple path container. The last item actually implemented that has some sliding navigation. But yeah, it doesn't come with anything out of the box, which also makes it very nicely extensible. So if you want some crazy flying transitions, you can build those. As I mentioned there, the paths container perform traversal method needs to be implemented, and that's what the simple path container does. So you can use that as a good starting point. And as an example here, we have a scaling transition. And the sliding one. So it works just like regular fragment or activity animations. And so we're going to take a quick look here at the perform traversal method. There's a lot of code, so don't want to go through everything. Mainly, the new view gets created. And based on whether there was anything before, we don't have to do an animation or transition. Otherwise, we'll do the animation. The thing to keep in mind if you do your own animation is that you actually need to destroy the old path or the old view after the animation is done, as there might still be some callbacks while the animation is happening. So that's the part all the way on the bottom of the screen here where the view actually has to be removed and then destroyed once the animation is completed. And within the perform traversal or within the path containers extended class, you also have a run animation method in this case, which here I just implemented those two scale and sliding animations. So yeah, first one scale, second one sliding, pretty straightforward. Yeah, so as I mentioned, Flow provides the backstack and therefore the history. There's a class called Flow Delegate that has to be implemented within your activity in order to provide callbacks for all the lifecycle events, resume, pause, but also for save instance so that the history can be saved to the persistence bundle. One thing that's nice is that you don't have to deal with parsables in that sense, or they're converted for you. But you can have a very simple, your screens can, for example, contain some complex objects for which you have JSON serialization. So here you build your own parsable, the state parser. And in this case, there's a JSON one. So you provide this to the Flow Delegate, and when your screens are persisted, it goes through whichever parser you provide. Two methods need to be implemented in your parser, the wrap and unwrap. Here within the Flow Delegate, the small snippet that whenever your activity calls through to unsafe instance, the history gets parcelized. And on the bottom here is one example. This is actually not from my sample project, but from a regular project where we use Jackson. So the annotation is a little different for JSON. But here you can see how within the screen I have states, and those states then get actually serialized to JSON and also stored with your history. So, in this case, your app may get paused, but you want to persist the state. So the screen has it, you come back up. Any of the previous values they provided to the screen are still there. So it's very nice and straightforward. So since it's so abstracted from the lifecycle, the presenter doesn't have any hooks left to the activity, but there are cases when you do need that, when you do need to know about on pause, on resume, or maybe on activity result. For example, if you do Facebook login, Twitter login, or you use some external activity to do scaling of your photos, or even if you have your custom camera and you need to know when on pause is called in order to actually shut down the camera so that you don't block any other applications from utilizing the camera. So you can, do something very easy there, and within your main activity, check whichever is the topmost view container and pass those events down, lifecycle events down. But I use a manager for that, and it works quite nice in that whenever there's a view presenter that does need these events, it automatically registers for any lifecycle events, and they can be processed within the presenter, and there's no direct link between the activity and any of your presenters. So here, so the activity has an instance of a lifecycle owner. That lifecycle owner has all the lifecycle methods within the activity you want to call the lifecycle owner. And then the lifecycle view presenter also has the lifecycle owner, but registers for any callbacks. So in the case of using the gallery picker to select some photos, the steps are, you click on a button, a gallery opens, and you actually need on result activity. I think so. And because I now have in my presenter the lifecycle support, I can actually receive the result from the picker and display it. So here, I use a lifecycle view presenter. Normally, there's just a view presenter class that comes with a Mortar, but in this case, I extended it, so I only have to actually override the particular lifecycle method that I need. So also, inject the lifecycle owner there as well as the activity. That way, you can actually call the intent to, or issue the intent to open the picker. And that was because earlier, when you set up the different scopes, you start from the root scope in your application, you add another scope within your activity that actually has a reference to your activity, so it can be nicely injected within your presenter. And then on activity results here, to actually get the data, process it, and update the nice image from the previous slide. Another thing, because of the dependency injection and just the capabilities that Mortar kind of brings, settings usually maybe you would have like some kind of manager that you would have an instance to everywhere. But in this case, actually, I use annotations for settings, and then have this particular settings module where my settings are defined, hooked up with the application root module, and then these settings can be injected within each of your presenters easily. The example here is first the annotation for user preferred name on the top. On the bottom left, you see the settings module where we actually provide or create the provides method within the Dagger module. And then on the right here in the settings screen, the presenter gets directly injected that particular settings value. And with get and set, you're nicely updated. So the takeaways, I think, from Mortar Flow are that you can create a really nice and clean view presenter, model view presenter if you want to. I am not very strict about always injecting the model via the screens module, simply because my data may come from other places, but you can also, Model View Presenter or just View Presenter, have both your view logic and your business logic nicely separated. With the Mortar scopes and object graph service bundled with Dagger, you can really keep your object graph nice and small and always just scope to whatever you need at that particular point. For me, big benefit are really the scopes for particular flows, compose flow, onboarding flows, where I need very specific values that are really not relevant to the rest of the application. And that's it. And yeah, you can test your presenters. These are the resources, Flow and Mortar, and then the sample app will be up on GitHub. And if there are any questions, happy to take those. Also, can just go through the app that you guys can take a look at and see how it works. Some of the code within is actually leveraged from Square's sample library as well. And then any of the things that I pointed out around lifecycle settings, those custom frame layouts are all within this project as well. It's kind of like my starting point for any new application. So we got that rotating screen. But yeah, you can start with questions. I'm just going to play with it.
Okay, thank you, Thorben.